So first we're going to investigate how our X variables are affecting the chance of churning. Going to try to get a feel for what the effect of changing each of our X variables is on the chance of churning. So we can look at the parameter estimates here. We'll do it first for just the ones that we haven't put polynomial terms on, because the polynomial terms are going to change the interpretation a lot. For voicemail messages, we've got this positive value, saying that the more voicemail messages, the more likely we are to churn. And we can interpret this by remember, we can get an approximate interpretation for this by looking at 1/4 of this parameter estimate is the approximate impact on the probability of churning for a 1 unit increase in the X variable. So one more voicemail message increases our chance of churning by this divided by 4, which is about 1.6%. International calls. Divide this by 4, we get about 2.5%. One more international call decreases our chance of churning by about 2.5%. Voicemail plan. This is a biggie. Here, voicemail plan of value 0 increases our chance of churning by this divided by 4. That would be 1.6 divided by 4 is about 0.4, so 40%. Not having a voicemail plan means we have a 40% higher chance of churning than if we do have a voicemail plan. International plan, not having an international plan makes us, what's that, divided by 4, we've got about 30%. We're about 30% less likely to churn. And for the others, we've got the polynomial terms. Okay, so now let's think about the polynomial terms. A good way that we can look at this is there's a graph down the bottom of the page that we can use, but in order to make things run a little bit faster, under plots here, I'm going to, instead of having all appropriate plots, I'm going to change to just a custom list of plots and only have the effect plots down the bottom. If I run this now my model's going to run much, much faster. It turns out it's making the plots that's the thing that takes the Enterprise Guide a lot of time. So now I plot down the bottom here. Predicted probabilities for churn equals 1. And the thing that's being measured on the x-axis here is number of voicemail messages. Okay, so what's going on here? As we get more voicemail messages, we're generally more likely to churn. You can see that by this probability increasing here as the number of voicemail messages increases. But in order to graph this, we have to choose particular values for the other x variables other than voicemail messages. And so up the top here, it's got international calls about 4.5, total charge about $60, customer service calls about 1.5. These are the other numerical variables, and so it's selecting the average values of those numerical variables. And then we've got 4 lines here corresponding to the 4 combinations of voicemail plan and international plan. So these colours are not very easy to see, but the first one is blue, that's this guy here. And so that is 0 voicemail plan, so not a voicemail plan and not an international plan. This is our blue line here. The red line is no voicemail plan, but yes international plan. And then our other two, what is this? Green, I think, down the bottom here. Yes, voicemail plan, no international plan. Very unlikely that we're going to churn in that case. And the, looks like black or something. Yes, voicemail plan, yes, international plan. That's this line here. And so generally what we're seeing is that as the number of voicemail messages increases, we're more likely to churn, but that effect is maybe slightly different at the various levels of these categorical variables. Now, the unfortunate thing, and this has always been frustrating for me with Enterprise Guide, is it only gives you one of these plots. It only gives you the voicemail messages plot. But we'd really like to see what the effect of total charge and number of customer service calls is. So it turns out there is a way to get those, but we've got to do something a little awkward. Under Modify Task, in the Model.Effects tab, you'll see voicemail messages up the top here for me. If it wasn't up the top for you, whichever of the numerical variables appears first in this effects list, that's the one that it's going to give you that graph for. Now, of course, it would be way too easy if we could just move them up the top, but we can't do that. But what we can do is take out voicemail message and international calls. So remove voicemail message, remove international calls, add back in voicemail message and international calls. And now we've got the same model with total charge up the top. So now when we run our model, that graph down the bottom is going to show us the effect of total charge. So this is our total bill for the month. Typical values for this are between $40 and $80. We get a few bills above $80, a few below $40. But for the most part, these bills are between about $40 and $80. And so what we're saying is that for the average bill of around $60, we've got the lowest chance of churning. As the bill gets higher than that, our chance of churning goes up. Until when we're getting a bill of above $80, that seems to be making us have a very high chance of churning. So interpreting this, it seems to me like what's happening is when we get a very high bill, we freak out and we're likely to switch service. Now, it seems strange to me that something similar is happening for low bills. So when we get a bill that's relatively low, we're also a little bit more likely to churn. So that's unexpected, but well, can't argue with the data. Seems like we've got a slightly higher chance of churning when our bill is $40 than we get when our bill is $60. Okay, so now let's do this same thing for customer service calls. Modify our task again. Go to Model Effects. Remove total charge. Add it back in. And now customer service calls is at the top, and that'll be the one that we get the graph of down the bottom. Alright, what are we seeing now? So customer service calls are generally running between 0 and I think the maximum in our data is 9. When we have no or 1 or 2 customer service calls, it looks like our chance of churning is generally pretty low. But as we get into the 3, 4, 5, 6 customer service calls range, our chance of churning is getting higher until we get up to about 6, 7, 8 customer service calls. At this point, we are very, very likely to churn. Our probability of churning is now very, very high. Okay, so interpreting this, it seems like if a customer calls into customer service once or twice, that's not much of a red flag. To us, that suggests that there's still a pretty low chance that a customer's going to churn. But once they get up above 5 or 6 customer service calls, well, they must be pretty unhappy with something. Something's going wrong with their phone or their service. And so at that point, they become much more likely to leave our service. Okay, so what we've done now is we've gone through and understood the effect of our numerical variables. Generally, we've seen that as voicemail messages rise, for some reason we're more likely to churn. For our total charge, when that gets very high, we're more likely to churn. And for customer service calls, once that gets up above 6 or so, we become very likely to churn. So knowing this then, we could set up some rules. For example, we could decide that we wanted to intervene somehow to try to be proactive about keeping our customers. If we see them get up to 4, 5, 6 customer service calls, since we know they're very likely to be churning if that number of customer service calls is getting up into that sort of area. We could do the same with our total charge. If we're going to send out a bill of $80 plus, and maybe we get proactive at that point and contact the customer, see if there's anything that we can do to bring that bill down. Maybe give them a one-time bill credit, something like that, in order to try to get them to stay with us. What's better though than doing this sort of ad hoc approach is to use our model to have a look at who is likely to leave, who is not. And so that's what we're going to do next, is how do we make the decision of who's likely to leave, who's not, and target those people who are likely to leave for intervention somehow.